Hello, this is Mr. Huber. In this lesson, we're going to look at geometric series. You got to remember, a series is a sum of a listing of numbers. Now, instead of an arithmetic series, where we have a common difference, now we're going to see a geometric series where we have a common ratio. And to be able to find the sum of a geometric series, this is the equation formula that we're going to use. So this will be the sum of some number of terms. Remember, n is the number of terms. So if it's a geometric series with 50 terms, this will be a 50. Okay? And then a sub 1 is our first term, still. R is the common ratio, right? Common ratio, different from when it was arithmetic and we had a D for common difference. Common ratio, and n, number of terms. So we don't need to know the last term. Or when we found arithmetic series, we needed to know the first and last terms. Now we need to know the first term, the common ratio, and the number of terms. And we put the common ratio in both these places and fill in the first term, the number of terms, and we can calculate this will give us the sum. Okay? So let's see how we can use this here in some examples. In this first example, we have a series. It starts with 3, it ends with 3072. So even though we don't need the last term to find the sum, we need the last term to know how many terms there are. We need to know what n is. Okay? In this particular example, we know a sub 1. A sub 1 is right here, 3. And we can find the common ratio, right? We're multiplying by 2 each time, so the r equals 2. Right? So we need to find out the number of terms. Those are the 3 things we need to find the sum of a geometric series. The first term, the common ratio, and the number of terms. So how are we going to find the number of terms? Well, we're going to use that last term that we see there, the 3072. 3072 is equal to 3 times 2 to the n minus 1. How did I get that? Well, that's going back to a sub n equals a sub 1 times r to the n minus 1. That's how we could find any term in a geometric sequence. When we were working with sequences, the lists of numbers, we could use this to find any number term. Well, now we know the number term, 3072. We know the first term is 3, right? We get that from right here. The common ratio is 2. We got that over here, right? Our A1 and our R. And then n minus 1. And so we're going to have to solve this for n. We can figure out what n is because that's our missing piece of information to be able to find the series and the sum of all this. Okay, so to do the calculations from here, we could divide both sides of this equation by 3. And we get 1024 equals 2 to the n minus 1. And then we'd have to figure out 2 to what power is 10,024. So 10,024 is 2 to the 10th power. Okay? And keep in mind right here, n minus 1 is equal to 10 then, right? N minus 1 is equal to 10. That means the n has to be 11. We could write that out if we want. So we know that n minus 1 equals 10. So n equals 11. So now I've got the 3 key pieces of information that I need. I've got the first term, the common ratio, and the number of terms. All right, so now I can find my sum. So to find the sum of this series, right, I'm going to use the formula. Go back up and use the pen on that. Write a little better than that highlighter. So we're going to have the sum of the 11 terms of this geometric series is the first term times 1 minus r to the n, that's an 11, over 1 minus r. So we have a sub 1, 1 minus r to the n, which is an 11, remember n is 11, and then over 1 minus r, so 1 minus 2. So if we perform these calculations, okay, this is going to come out to negative 6,141 over negative 1, which is then a positive 6,141. So if we added up all the numbers in this list, including all the ones we don't have in here, we would end up with 6,141. Okay? This is how we can find the sum of any geometric series, okay, that has a finite number of terms. Right? We need the a sub 1, the r, and here we had to find out what n was. Now let's find another sum here. Remember sigma notation. Sigma notation here. So in this case, we need a sub 1. We have a sub 1. all right? We can read what a sub 1 is or we can calculate what a sub 1 is, excuse me, by doing a sub 1 equals 4 to the 0.5 to the 0 power. Right, we're going to find the first term. We're putting a 0 in here for n. This will tell us what the first term is in our series. Okay, this would be a sub 0, actually, right? The first term. So this is going to be 4 times 0.5 to the first power. I think this first power is 1. So 4 times 1, this comes out to 4. So this is our first term, right? This is our first term. First term. If we were going to write a list, we'd start with 4 plus, and then keep going all the way to our last term. Okay? Our common ratio is right here. R equals 1/2, which is 0.5 as a decimal. Doesn't matter which one you use. Okay? And the number of terms. So for n, we're going to do 20 minus 0 plus 1. All right? We always do the 20, whatever number's up here on top of the sigma notation, minus what we're starting with. So 20 minus 0, and then plus 1. Because you have to remember we're including the 0 and the 20. So that's why we have to add that 1 at the end. So n is 21. Right? So now I can find my sum. Okay? The sum of the 21 terms here is going to be 4 times 1 minus 0.5 to the 21st over 1 minus 0.5. I like to put it in as a decimal. I think that's going to be easier. But if you put 1/2 in instead of 0.5, it'll come out the same. Right? And so when you do this calculation, it's going to come out to about 8 if we round it, 7.9, a bunch of 9s. So depending on where you round to, so we'll say it's about 8, all right, for the sum of that series. And we need to know the first term, the common ratio, and the number of terms. Those are our 3 pieces of information we need to be able to go in and figure out what our sum is going to be, okay, our series here. To find the series, we need the first term, the common ratio, and the number of terms. Those are our 3 key pieces of information. All right. Before we see some more examples, a little credit for a quote here. I like this quote, and I'm going to ask you to send me one of your favorites as well. Okay, it says, "I cannot do all the good the world needs, but the world needs all the good that I can do." So you keep doing your best, right? That doesn't mean you're going to solve every problem, but if everyone's out there doing their best, good things will happen. So continue to put your best foot forward in all you can. Help out as many people as you can each and every day, and things will go smoothly and as well as they can for everyone around you, and hopefully others can do the same. What I'd like you to do, you know, I'm big on some quotes here. I like providing quotes and take some inspiration from certain ones. This is one I particularly like. But I'd like you to send me a quote of your own that you find particularly inspirational. It doesn't have to be your own quote, a quote from someone else if you want, but one that you use that you really take heart to. Maybe it's one you've heard before from me or from somewhere else. And if you do send me a quote that you find particularly inspirational and worthwhile, I'll give you a little extra credit for that. So just email it to me before the start of the next class period. All right. Now that we've maybe gotten some inspiration from that quote, let's do all the good that we can here. All right. An infinite geometric series with a common ratio that is absolute value less than 1. So infinite means it goes on forever. It has no end. We can find a sum of an infinite geometric series. Even though it doesn't end, okay, we can find the sum as long as the common ratio is less than 1, because it means that the numbers are going to get closer and closer and closer to something, typically 0. So as they get closer and closer to 0, adding such a small amount on, the sum really isn't going to change, so we can get an idea of what that sum would be. Okay, that means the numbers converge. These are the 2 key terms to know here. Converge. Converge means the numbers go toward something. Okay, converge. The numbers are going increasingly towards some amount, usually getting smaller and smaller towards 0. If things converge, they're coming closer together. Okay, and then diverge means going away. So the numbers, when the common ratio is greater than 1, you're going to get numbers that get bigger and bigger and bigger and bigger. We'll see some examples, okay? If our common ratio is 3, we're going to multiply by 3 each time. The numbers are going to continue to get bigger and get further and further away from what you started with, or from 0, more importantly. Converge, they're going to go smaller and smaller numbers, because when our common ratio is less than 1, like 1/2, right, that means you're cutting the numbers in half each time, okay? And so when our common ratio is less than 1, and the absolute value of it, we can find a sum here using this equation. We take the first term over 1 minus that common ratio, and that'll give us an idea of what that sum would be, even though it's infinite. All right, so let's take a look at how we can use that in some examples. The first thing we have to do is figure out if these converge or diverge. If they diverge, we can't find the sum. Okay, if it converges, we can. All right, and if it, then we're going to find the sum for those. So this first example, our common ratio here is 2. R equals 2. So this diverges because the common ratio is bigger than 1. R is bigger than 1. Okay, the absolute value of R is bigger than 1. So it diverges, and there's no sum. Okay, this next example, our common ratio is 1/2. Okay, which is 0.5. If you want to put that into the equation, you're cutting the number in half each time. Dividing by 2, same as multiplying by 1/2. So this converges, and it means we can find a sum. So the sum is going to be the first term over 1 minus the common ratio. So that's going to be 10 over 0.5, which comes out to 20. So our sum there is going to be 20. All right. Let's see a couple other examples. Again, you should try these. Pause the video. See if you can figure out how to determine if this converges or diverges and find the sum if possible. All right. So number 5 here, it's written a little differently because it's in summation notation. The key first thing is going to be find out what the common ratio is. Okay, it's not a list, but we can identify the common ratio right here. R is negative 1.5. That has an absolute value that is greater than 1. Right? The absolute value of negative 1.5 is 1.5, which is bigger than 1. So this diverges, and we can't find a sum. Right? Our numbers would be getting further and further away from 0. We keep adding on more and more. The sum's just going to grow to infinity, so we wouldn't be able to get a sum for it. Okay. Number 6 here, we're going from 1 to 1/2, 1/2 to 1/4. So hopefully you recognize, if you can't, for the common ratio, if we do 1/2 over 1, that's 1/2. 1/4 over 1/2. When you're dividing by a fraction, that's the same as multiplying by its reciprocal. No, not 2 over 4, 2 over 1. Okay? So instead of dividing by 1/2, it's the same as multiplying by its reciprocal, 2 over 1. That's 2/4, which is 1/2. So we have a common ratio. The common ratio is 1/2. We're cutting these numbers in half each time. We're going to find a ratio, take a number, divide it by the number before it. Take the number, divide it by the number before it. It's coming out to 1/2. So our common ratio is 1/2. This means we can find the sum. So the sum is going to be 1 over 1 minus the common ratio, which is 1/2. Again, put it as 0.5 if you want. 1 over, I'm going to write it as a fraction here. All right, let's change that to a fraction in this one. So 1 minus 1/2 is 1/2. Okay, just so you can see how it's the same with a fraction. So that's 1 times the reciprocal of 1/2, 2 over 1. Dividing by a fraction is the same as multiplying by its reciprocal. Okay, and we're going to end up with 2. So our sum there would be 2. Right, so if we have an infinite geometric series that converges, again, gets smaller. You can see these numbers are getting smaller and smaller, closer and closer to 0. All right? As these numbers converge towards 0, we can still find a sum. If our common ratio's absolute value is bigger than 1, then the sum diverges, or the series, excuse me, diverges, and we can't find a sum. All right? So know 2 ways to find a sum. When it's finite, those are the first ones we did. That's where you need to know the first term, the common ratio, and the number of terms, and we can find a sum. And then if it's an infinite series, geometric, but it converges, we can find a sum still as well. All right, so we'll be practicing some more of these and continue to know how we can find sums of our geometric series.